something like this, x is greater than 3, is 2 a solution? The answer is no. What if they say that's 5? Would you say that's a solution? Is 5 greater than 3? Yes. Okay. So how about 3? No, because 3 is not greater than 3. What if I had it like this? X is greater than or equal to 3. Would 3 be a solution to there? Yes. In that case, it is a solution. What if I say graph all solutions? All solutions. And this is kind of stuff from the first 2 chapters, 3.1 and 3.2, that we're kind of skimming over. Graph all solutions for x is greater than 3 on a number line. A number line. So if they wanted you to graph this thing here, all you do is you make a number line. Now first you get the number line drawing tool, and you put arrows on both ends of it, and you make it colorful, like red, and you draw a number line. There's a number line. It should be a solid number line, but that's okay. And what you do is you take you just kind of draw in here, there's 3, and then you go this way, and you say, here's x. All numbers greater than 3. So this would be x is greater than 3. How about if I shade in the dot? Do you know what the difference between shading in the dot and using an open dot is? Yes, Justin? Greater than or equal to. So if you shade in the dot like that on a number line, that means x is greater than or equal to 3. Okay, if you don't shade in the dot, then it means 3 is not included. So I would put like 0 here and go 3 there, and then you could do that. What if I wanted to graph m is less than -1? Could you do that? Could you graph m is less than -1?
No.
You couldn't?
No.
Why not?
Would it be negative then?
No, you could graph it. You just have to do it. Yes. You say, yes, I could do that. So the way you do that is draw a number line, and you put a point where you think -1 would be, maybe over here. Should it be an open circle or a closed circle if m is less than -1? Open circle or closed circle? Open, okay? So you put an open circle there, and then you go like this, and I could use mine. I could use this tool. That's what I do. I could go like this. Going down that way, okay? And what you also might want to put somewhere on your number line is a 0, okay? So here's 0, here's 1, and so on and so forth. So that's how you graph points on numbers. Is that hard? No. Okay, so that's section 1, which we really kind of skimmed over, okay? Section 2 is solving inequality equations with addition and subtraction, okay? 3-2. And that's pretty easy as well. So if I have something, let's get a new page here. Like 3 is greater than or equal to x minus 1. And they say solve and graph. A solution. So all you do with this, you do it exactly like you're solving an algebra equation. Right? Okay? So what would I do if this were an equal sign? How would I solve this? What would I do to both sides? Hello? What would I do to both sides there, Blake? If this were just an equal sign here? How would I get rid of this 1 over here? add 1, right? Add 1, add 1. Now I get x is less than, this is red, x is less than or equal to what? Hello? 4. Okay? And that's my answer. So now I graph it. Okay? And so I take my number line. I don't like this code. I'm going to change it to blue. Okay? So here's my number line. I'm going to put a point at 4. Do I make that a shaded in dot or an open dot? X is less than or equal to 4. Shaded in or open? Morgan. If it says less than or equal to, is it open or closed? It's closed. If it's less than or equal to, it's a closed dot. And which direction do I go from there? Which direction? Which direction, Alyssa? Right? This way? No, because it said x is, so this is red, x is less than or equal to 4. Where are all the numbers that are less than or equal to 4? Hello? Where are all the numbers that are less than or equal to 4? Jordan?
Left.
Left. Okay? So from this dot, you're going to go this way. Okay? So I'm going to watch this. I'm going to go this way from 4. Ooh, I like this. It looks like it's surfing or something. There you go. So that's the way you do that. Okay? So to check if something is a solution, you can plug in a number. What's a number less than 4? What's a nice easy number less than 4? What's a nice number?
156.
What? That's not a nice number. How about a nice number? Like 2. Okay, so say I have 2. Whoops. I don't want my thick pencil over it. So say I have, over here I have 2. If I plug in 2 in here, do I get a number that is less than 3? Can I get a number that is less than 3? What's 2 minus 1? 1. Is that less than 3? Yes. That's less than 3. Okay? So that's section 3-2, solving linear inequalities by addition and subtraction. Okay, so we're assuming that you know how to do that. Okay? Pause this. Okay? We're working on it. Alright, so let's get a new sheet of paper. Say I have something like 2 is less than, let's say 2x is less than 8. And they say solve and that's not an end, is it? Solve and graph. Okay? What would I do? Tell me how we solve this inequality. Justin. Divide both sides by 2. Okay? So that's what I'm going to do. I'm going to divide this side by 2 and that side by 2. And this goes away. And I get x is less than what? 4. Okay? Very similar to the last problem. I'm going to get my line tool. See if I can draw a line. Dot. I'm going to put a dot at around where 4 should be. Should that be an open or closed dot? Open or closed dot? What do you think? Who said open? Why, Sarah? It's not equal to. Okay? So I'm going to put an open dot there. Alright? And which way do I go? Left or right? Marco, left or right?
Right.
Right? Alright, so if this is 4, are these numbers less than 4?
No, it's left.
Left. Thank you. Okay? So I'm going to shade all the points going to the left. So I'm going to kind of go this way with that. Okay? All the way on red.
I'm sure Mr. Leader has mentioned this
you keep the variable,
Like it is up there, keep the variable on
if
the
you
left.
keep the letter on the left?
Yep.
Okay, yeah, so then the last one, I had the variable on the right side, that's why I think they were kind of getting confused.
Yep.
Okay, good point. And then, so if I put like a 0 here, let's pick a point. Say I want to know, is 5 a solution? Is 5 a solution?
Yeah.
What do you think there,
It's
Jordan?
a solution.
5 is a solution to this?
Oh, is less than 4? No,
Yeah.
It's
Why not?
because it's bigger than 4.
It's bigger than 4, and it would, where would it be on the number line?
Out to the right.
To the right, right? So it wouldn't work. All right? Yeah. Next one. Got. Let's look. Got some more examples here. So something really weird happens when you have division. Right? So say we have, like, we'll do this for division. y2 negative 2y is less than or equal to 4, 5, let's do something interesting. 5. Okay? Let's see what happens here. Okay? Negative 2y is less than or equal to 5. What do I do to solve this? Someone else. What do I do to solve this? Lily, can you tell me what I do to solve this? How do I get rid of this negative 2 over here? Morgan, can you tell me how I get rid of this negative 2 over here? No. How do I get rid of that negative 2? Catherine, divide by 2? Or what? Negative 2, thank you. So I divide by negative 2. Right? And divide by negative 2. And I get y is less than or equal to 5 divided by negative 2 is, what's that? Negative 2.5. Thank you. Negative 2.5. Now let's try to graph this. Okay? Let's try to graph this. So here we go. Less than or equal to negative. Yeah, but I don't know. Okay? We're going to do this. All right. So let's put 0 here. Okay? And let's go 1, 2, negative 2.5 would be about here. Open circle or closed circle? Open circle or closed circle? Open circle or closed circle here? Closed circle. Good, Jason. Okay? Closed circle. Which way do I go? Which way do I go? Left or right? Left or right? What do you think, Lindsay? Left or right? Left. Good. Okay? So let's go left from there and make it a little bit thicker. Okay? So I'm going to go left. So here's negative 1. Whoops. I don't want that to be thick like that. So here's negative 1. Here's 1. Here's 2. Let's pick a point and see if it works in my equation. Okay? What's a point that is less than negative 2.5? Who could give me a number that is less than negative 2.5? What's a number that's less than negative 2.5? Kieran? What's a number that is less than negative 2.5? Negative what? Negative 6, okay? So we're going to pick this point way over here at negative 6. And I always want to check to see if this works. So what? Negative 2y And this is what we started with, is less than 5. And I'm going to take, Karen says negative 6 should work, so I'm going to take that and plug it in over here, okay? Negative 2 times negative 6 is less than or equal to 5. I'm going to put a little question mark here because I'm trying to check to see if it's right. What's negative 2 times negative 6?
12.
12 is less than or equal to 5. What do you have your hand up about there, Britt? Is that a true statement? Is that true? Is that true? Is 12 less than or equal to 5?
No, not.
It's not, right? So no, it doesn't work. So we did something wrong. Does anyone happen to know what we did wrong? Hunter, what did we do wrong? Yes, it should have been drawn to the right instead of the left. But that would mean that this is greater than, right? Right? Means all the numbers greater than. So here's the rule, okay?
This is important, you guys.
It's
Listen up.
important. And it's just kind of weird, like that's the way the math works. If you have an inequality sign like this, okay, and you divide by a negative number, this thing flips the other direction, okay? So you got to really remember that. Even kids in like my advanced pre-calc class, they forget that rule all the time, okay? So if the sign, if you're dividing or multiplying by a negative number, this thing flips. So what I should have had here, this should have changed to, if I did it correctly, this should have changed to y is greater than or equal to negative 2.5. And then I should have shaded up this way, okay? And then if I did take a number like 2 and plug it in here, negative 2 times 2 would give me negative 4, and that would be less than or equal to 5. But we'll do another one.
All right, let's just give them a minute to write in their notes that when you multiply or divide by
Yeah,
a negative.
I'll write that down.
Sure.
Okay.
Just to get that in your notes because it's kind of important.
With, whoops, I can't take mine back. With inequalities. And those are things, that's L, right? That's L, right?
Yes, yes.
Inequalities. I'll look up here. Okay? With inequalities, and those are things like greater than, less than or equal to, greater than or equal to. Okay? When multiplying or dividing.
It's either, you guys, multiplying or dividing. Our initial example was division, but I'm sure we'll do an example with multiplication. And that's also another reason why it's important to check. When we've asked you to check in the past when we were just doing regular equations, it'll be especially important to check your answers now that we're doing these inequalities.
Right? Important to know. With inequalities, multiplying or dividing by a negative, the inequality flips directions. Done? So, shall we do another one?
Sure, I think so.
I think so. So let's do...
And maybe put a couple stars by this. I wouldn't get rid of it quite yet. People are still writing. Let's just give them a minute to catch up.
So instead of negative x, negative 6. So negative 6 divided by 2 would be